Yeah, good day, everyone. Today we have the chance to discuss data center facility, which we narrow to data center development. First, as we move on, have we ever asked ourselves a simple question? Let's just have a quick question. We access the following app virtually everywhere in the world. We can see every part of the world. We can access our Facebook app. We can access Google App Engine, Microsoft Azure platform, and so on. Can we ask ourselves a question? Where exactly does this application sit? Where exactly in the part of the world is this application sitting? Where is this server that makes it possible for everyone to access at the same time at any time? That is a question we need to answer as we discuss. Quickly, a data center development, which is our direction today. A data center is a physical environment facility intended for housing computer system and associate components. We have different set of gadgets being housed at a data center. So this can be comprised of computer system and staff that maintain them. In a data center, after we have these gadgets being put in place, we need staffs that need to manage the gadgets. So the necessary physical environment facility encompasses power supply with the possibility to ensure backup. When we have our gadget set up, we need to power it up, and this power must be consistent. When there is a failure, there must be a backup to take it up. So also we have some set of necessary communication equipment, which are like switches and the router, and all network communication are put in place in a data center. What we have as well in data center is a perfect cabling system that makes everything works hand in hand. We have different system of cabling, which we discuss further in our classes. We also have one powerful structure that's very important in a data center, which is the air conditioning system. The air conditioning system is well structured because the fact that the gadget in the data center generates a lot of heat, and the heat need to be neutralized so that the devices there can work perfectly. So as we move on, we talked about the examples of up-to-date data center service. In a data center, we render different set of services which goes across hardware installation and maintenance. So we have a word called a colocation in the data center, whereby a third-party data center can create a space for another company B to come and collocate and put in their hardware for them to enjoy stable power supply, good environment, cooling system, and so on. So data center service can also be, we have a service called managed power distribution, in the sense that which make the data center to be classified as a tier 1, tier 2, tier 3, and tier 4. So we also have a backup power system that helps to bring up the data center in case of any downtime. Then we have set of data backup archiving to save in case of just like a complete replication of what is going on in one region of the data center to another. Then the managed load balancing. The essence of this is when you actually have too much of traffic, and you actually want to do a load balancing, and the traffic can go to this region of data center and the other. So to go on, we have managed email and messaging, server colocation and hosting, and the likes. So we quickly move on to data center organization. In the organization of a data center, we had in the organization, we have number one, which is the rack level physical organization. In the data center, we have rack system, which you can see in the picture. The data center is generally organized in rows of rack. You can see on the screen where each rack contains a modular set such as server. In this rack, we have a standard rack, sometimes referred to as 42U rack. In this rack, it contains server, switches, routers, which are perfectly positioned. So the standard rack, like I said, is about 78 inch, and it's otherwise called a 42U rack. Typically, each rack takes a number of modular rack mounts that house the gadgets I mentioned earlier, the server, the router, and the switches. So a standard rack is a 42U rack asset. When completely filled, the sophisticated rack itself may vary greatly in a simplest case. So these racks are where we position these our devices, and the racks on the floor we have a kind of a floor that is being raised for a perfect cooling system. So also we have in the data center is the electrical and cooling infrastructure. The major thing about the power of a data center, because this gadget that are in the data center consumes a very lot of megawatts of energy. So actually what happened is the fact that a very high voltage of power is being moved down to the data center. So there are a lot of conversion step down system that happen. So example, a 33 kV line, three phase is being moved down, and this 33 kV line can be stepped down up to 240 to 480 volt three phase for routing through uninterrupted power supply. That is, this 33 kV can be stepped down to 11 kV. Then 11 kV can be bring down to 415 voltage. Then the 415 voltage can be stepped down as well to a 280 to 480 voltage, which is adaptable to the uninterrupted power supply. The essence of the UPS is to create a separate backup for this supply for the meantime. So the UPS accepts the 280 to 480 volts three phase. Then from the UPS, you have a clean, perfect supply to give out a perfect smooth 240, 280 to 480 voltage to the gadget. So as well, in under this UPS voltage can be moved down to like 3 to 4 voltage that are being accepted by the servers and other devices. So what we need to discuss as well is the cooling infrastructure in the DC. The cooling infrastructure in DC are systematically arranged in the sense that in a data center, we have a cooling system like a large chiller plant, fans, air circulation system, because for the fact that the servers, switches, and the routers and other gadgets put in place in the data center generate a lot of heat, which this heat, if not being evacuated, it can damage the device, make them freeze, and not them to make them to malfunction. So that's, like I said earlier, the data center server racks are generally placed on a raised plumb, that where there are two major advantages of this raised plumb. That sometimes your cabling system can allow you to do the cabling underground. Then the second essence of the raised plumb is for you to bring in a cold air, just like what you have on this diagram. You can see the rack, which is otherwise known as the computer room air conditioning system, bringing up a cold air, which is about 21 degrees Celsius. You can see the arrangement of the rack. The rack are facing each other. This is the face-to-face, back-to-back system, which means the heat emanating from each of the devices are up to 40 degrees Celsius. Like this, 40 degrees Celsius is coming from this back. The other rack back is facing the back to this. Then the 40 degrees Celsius are being pushed up by the code coming from the raised floor that are being generated by the crack system. So this 40-degree warm air, because they are less denser than the cold air, are being pushed up, then back to the computer room air conditioning system. These air are then being cooled by the crack system, then pushed through the raised floor, then back to the front end of the rack. So this makes the system perfect and continuous. This is a powerful method of cooling a data center, and other system that you use, which we also call the in-rack cooling system, we discuss further in our class. So we move on to the future direction in the data center evolution. The traditional data center that we have are now been going obsolete. The way we position the data center traditionally, whereby it's being owned by a physical company, let's say a single company, for the setup right from the physical infrastructure. So, however, the forces in play are resulting in data center moving towards much more complex ownership scenario. Now, someone that owns the whole of the data center can bring up a services to another company. Come and set up, have your devices in my data center, and it's going to be a kind of a virtualization consolidation. So, as a result of the emanation of virtualization across data center has allowed a much higher level of aggregation. So that's why we can do what we call outsourcing of the data center. We discuss much better as we move on. Now, virtually, the concept of the modern virtual data center can be divided into four. We have the physical infrastructure layer, the virtual infrastructure layer, the virtual infrastructure coordination layer, and finally, the service provider layer. So I take time to go through it one after the other. The physical layer of a data center, like I try to explain, it's actually the where you have the devices itself. They are the points where you aggregate all your device. So in this layer, if you look at the diagram that is being shown at this point, this diagram, you will see that the physical layer is at the bottom level from the diagram, which is the physical layer on the data center. So this physical layer manages the physical infrastructure, otherwise known as the server farm. That's where you have your physical server being put in place, installed in a given location. Because of the increasing cost of power consumed, space occupied, management personnel required, server farms are already being located closer to source of cheap electricity. Like I mentioned, the resources that are needed in the data centers must be provided. So you need a very powerful, stable electricity. So you can locate your data center close to these resources. Then we have a water, because you need a chiller system, then a spacious land and manpower. These locations are by their nature geographically removed from areas of heavy service. For instance, you can have your data center far distance from the city, where you can perfectly manage the data center. So as we move on, the location, like I said, are geographically removed from areas of heavy service demand, and thus development in ultra high-speed networking over long distance are essentially enablers of such remotely located server farm. The fact that you have moved this location to a long distance and brought up the system of creating technologies that allow you to push your traffic at a very high speed. So that's the physical layer. In addition to the management of physical computing hardware, the physical layer can allow for larger scale consolidation by providing capability to carve out a well-isolated section of the server. That is, you can do what we call a co-location. That as a result of that, you can create different physical layer section for other companies to bring up their devices. Then now, the next layer we're going to be talking about is the virtual infrastructure layer. The virtual infrastructure layer are typically a virtualization capability available in individual server. So you can have a services of these physical layers, bring it up together, where you have your virtualized server that can individually serve you the network and the storage element to support the notion of a virtual cluster. So what we have in this is that there will be efficient access to large amount of storage necessity, which is not you might not be able to enjoy that when you have a kind of a physical infrastructure. So you render this kind of service as well, a virtualized service to companies, whereby a company A can come to collocate. We need a virtual server. This virtual server might just be have an application running on it. So they don't actually need to have the physical server put in place. They needed a virtual server. But for this kind of services, there must be a perfect service level agreement on the fact that you need to discuss the compute power followed by the network and the storage that need to be accessed by the virtual server. So this can actually run on the DC. So however, it is also conceivable that the virtual infrastructure service are actually under the control of the infrastructure provider, because you are the one that use a virtual technology to set up the virtual server. So you need to manage the storage, you need to manage the computing power, then you need to manage the networking power. So we quickly run through the next part of the layer, which is the virtual infrastructure coordination layer. The purpose of this is to tie up all your virtual server patches. Just take, for instance, a company A is having a virtual server co-location at maybe in the Europe section, and also have another virtual server co-location in Asia. Then you also have another one in Africa, and this virtual server need to work hand in hand. So it is at this layer you do a kind of trying to converge all these virtual layers. So you need to coordinate them. They might need to talk to each other. So it is at this this is actually used when you are trying to avoid a disaster. That's where you use the disaster recovery, whereby if one region goes down, then you still have your system running on at another region. So these are like of a coordination of the virtual structure server. So finally, we discuss the service provider layer. The service provider layer is responsible for managing and running application on the distributed virtual data center, like I mentioned earlier, which the service provider will require a substantial visibility into the physical configuration. This is at the point where you have your application running. So you need to consider, look at the whole layers and see if they will be able to withstand the pressure of the app, or it can actually manage the application that is on the service provider layer. So the question we ask ourselves is a very simple one. For instance, the Facebook app must be sitting on different set of infrastructure in every region, and that's why you won't notice any downtime of your Facebook app. We access it from every part of the world. So you can have this application sitting on the service provider, which happens to be the owner of the Facebook. So they can have a virtual infrastructure coordination at different parts of the world: Asia, Africa, Europe, and the like. So this can actually be set up on a virtual server. Then you can have the virtual server sitting on the actually the physical infrastructure. So the question is, where does the physical infrastructure being located? It can be in every different part of the region, and you can. That's why we are able to access it. So we continue in our next class. Thank you very much for listening.